Hello student. Last time we discussed electric potential at a point which is given by V equal to KQ by R. Today I am going to define the another term that is called electrical potential difference. We have defined this term in gravitation class 11th also. Electrical potential difference between 2 points in an electric field may be defined as the amount of work done in moving a unit positive charge from one point to another point in the electric field of given charge. I repeat, in moving the test charge from one point to another point in the electric field of the given charge. It means the potential difference between A and B is given by VA minus VB is equal to work done in moving from A to B divided by that test charge. This is called, you know that we already find the potential which is given by KQ by A. If I suppose this point as the origin, the distance of this as RB, and the distance of this from this plus Q charge is RA, then what will be VA? That is the potential of this charge at this point, that will be KQ upon RA. Similarly, what will be VB? It will be KQ by RB. If you substitute in this, you get the potential difference between A and B is equal to KQ upon RA minus KQ upon RB. So it is simply the difference of potential between, or it may be defined as work done moving from A to B divided by this. So next question comes, what is the unit of SI unit of potential difference? It is similar to the potential, that is VOLT. Since it is a difference and difference is also expressed in terms of same quantity, or it is equal to joule per coulomb, since it is used to measure this. Next question that come in our mind, let us find the electric potential due to dipole at a point. Let us find the electric potential due to dipole at a point. Which point? At a point on its at a point कहाँ पे है? फर्स्ट हेडिंग इज एक्सियल लाइन. बड़ा सिंपल आर्टिकल, जस्ट चेक बच्चे. प्लस क्यू minus q. This is a point P, this is dipole, A point, P point. From the central, this distance I suppose R, you know that this distance is A, this is also A. From this to this R, what will be this? It will be R minus A. And what will be this? It will be R plus A. So I want to find the potential, very easy, since it is a scalar quantity, so you just add it. The potential of this plus potential of this. Potential of this will be KQ upon R plus A. Potential of this will be, hanji bache, KQ upon R minus. Why it is negative? Since I have to take this negative sign also. Why you have to take this negative? Since this quantity is a scalar quantity. Take beta KQ common, LCM R plus A, R minus A, cross multiply R minus A minus R plus A. KQ A plus B, A minus B, A square minus B square. A square minus B square. So if you solve this, so here you get minus 2A, here you get minus 2A. So it comes out to be minus K Q2A upon R square minus A square. Look at this. What is this? This is called dipole. moment, it means potential will be equal to minus Kp upon r square minus a square. Clear? If you have a short dipole, for a short dipole, you know the condition A is approximately equal to 0, then potential is minus Kp upon r का square, then the formula. So what is difference? That for a look at this basic formula, it is kq by r for a point charge. But if it is a dipole, then for a dipole, if it is a far point charge, potential is inversely proportional to r square. But for a point charge, it is inversely proportional to r. It is clear. So this is the case when I find the potential due to dipole at any point on its which axis? हाँ जी बच्चा, at a point lying on its axial line. Let us find the second case when it lies on its equipotential surface. Very simple article. Plus q charge बच्चे, minus q charge. This is the equatorial line. Do you know that this distance is a? This is also a. I want to find its potential at this point. No problem. Potential join this. One thing is clear. This if this is r, both distance will be same. R square plus a square. This is also r square plus a square. You call this A, B, and this point as a C. So potential at C is the sum of potential plus Q plus potential at this. Formula for first will be KQ upon R square plus under root. Clear? For second it will be minus KQ upon. If you see, answer will be. It means the potential at this point due to dipole is equal to 0. Clear? यहाँ से एक बच्चे एक शॉर्ट आंसर क्वेश्चन दैट आई गेट, इज इट पॉसिबल दैट इलेक्ट्रिक फील्ड इन ए रीजन इज ज़ीरो बट पोटेंशियल इज नॉट ज़ीरो? हाँ जी बच्चे, इज इट पॉसिबल? यस, आंसर विल बी yes. For example, in case of dipole, at its midpoint, if you find the potential, what will be potential? But electric field is not 0. In the other example, you will find that in case of conductor, in conductor inside the electric field is 0, but the potential is not 0. In case of conductor inside electric field is 0 but potential is not 0. So if somebody asks is it possible, answer will be yes sir, it is possible. Next question that comes very important. The question is show that electric field is negative of potential gradient. In class 11th, we defined when you said something gradient, it means that quantity divided by distance. That is called potential gradient. You know that plus q charge, there is minus q charge. This charge move from A to B. Let us suppose, oh sorry, you are not taking dipole. Just take plus q charge. Another charge you move q naught from A to B in the electric field of this charge. So when you move this charge from A to B in the electric field of given charge, you did some work. That work you move from A to B. If I suppose that distance dx, what will be that work done? F dx dot product. F dx dot product. What is F? F is the force experienced by this charge, which is at this point B, given by this charge. And you know that the formula is q naught e dx. Why I remove dot product? Since theta is 180 cos 180 is minus 1. Now it is minus q naught. Okay, this is the work done moving from A to B. Got it? Divided by charge is equal to minus e dx is equal to minus e dx. Today I defined this term as when you move one charge from one point to another, then this thing is defined as, हाँ जी बच्चे, this thing is called what? This thing is called potential difference, and it is equal to minus ETX. That difference I'm writing with dV. dV means जैसे dx लिखते हैं, dV means difference. So it means I prove that E equal to minus, yes, E equal to minus dV by dx. This is my correlation that E is electric field is a negative of potential gradient. Once again, what is dV? dV is potential difference and dx is the distance between these 2 points where the. Now from this, one thing is clear. Number one, electric field is in that direction in which potential decreases is steepest. Electric field is in that direction in which the potential negative potential decreases steepest. Always remember. Second, the important thing is if E equal to 0, this implies dV by dx equal to 0. This implies dV equal to 0. It means V equal to constant. It means if in some region electric field is 0, in that region V may be 0 but may be constant. That constant region is called, my next topic, equipotential surface. As the name implies, equipotential, it means the potential is same at every point. So let us discuss next, that is called equipotential surface. So next topic बच्चे, that is about equipotential surface. And this is also important exam point of view. Equipotential surface. So EQ, look at this name, EQ plus बच्चे potential. EQ means same क्या है? Potential. ऐसे surface, ऐसे region जहाँ पे potential change नहीं करेगा, that surface is called equipotential surface. That surface is called equipotential surface. Let us discuss some of the properties of these. We have given, I have given you notes. You can read from the notes too, but let us discuss one by one. First property, one thing is clear, that V is constant on the surface. If V is constant, what's about dV? Why it is 0? dV is the difference. When I said V constant, its value is 6 volt. When you take the difference, 6 minus 6 will be. It means for such a surface dV is 0, and we already defined E is equal to minus dV by dx. Now if E is 0, it means dV is 0, it means E is also. So electric field is 0 on such a surface if it is a equipotential. Number 2, no work is done in moving the charge on equipotential surface. No work is done in moving the charge on equipotential surface. Why? I just prove you. We prove that on equipotential surface dV is 0 because V constant and also we define that. How you define potential? It is work done in moving the charge divided by that charge. If dV is 0, it means that work done will also be. So many times CBSE asked the question from this concept. I discussed with you, very easy, just check with you. Short answer question, how CBSE asks. Let us suppose plus Q is placed at the center of the circle. A charge moved from A to B on the circumference of this. Calculate the work done. Calculate the work done moving the charge on the circumference of this circle if charge is placed at the center. Another way to ask this question. Again, the center of circle charge is placed. A charge is moved from A to B via this and second A to C via this. When you move from A to B, work done is W1. When you move from A to C via this, then work done is W2. So which relation is correct? W1 equal to W2, W1 is greater than W2, W1 is less than W2. Sometimes CBSE asks this question. Another way to ask this question, just check with you. Let us suppose this is a conducting plate. Two metal plates are placed in near to each other. This plate is connected to a battery and then earthing. Got it? This plate. A charge is moved from this point to this point, that is from A to B. The potential of this is 6 volt and charge which you move is 3 millicoulomb. The question is calculate the work done moving from A to B. Now listen carefully. In all the cases, whatever case we discuss, in all the cases, answer will be 0. Why? Since this is placed at the center, so potential will be same. And if potential is same, this become equipotential surface, and on equipotential, the work done will be 0. In the similar case, whether you move from A to B, A to C, this is a equipotential surface, work done is same, so answer will be this one. This is a plate. This plate is on which volt? 6 volt. So battery, all the points on this and this plate is at 6 volts, so it become equipotential surface. If it is a equipotential surface, again the work done will be 0. So many question. If I give you another question, you can try that. This is square. At the center of square there is a charge of plus 6q. Another electron move from A to B. Calculate the work done in moving from A to B. Again the answer will be, since it is at the center, it will produce the same potential, it will become equipotential, work done will be 0. Clear? So this is my second property. Now I come to third property. What is third property? Third property, that electric field always normal to surface of conductor. Electric field is always normal to surface of conductor. Why? I justify. I already proved that work done is equal to 0 on equipotential surface. Now also the work done is given by E vector dot dl vector. This is also 0. Now if dot product is 0, what will be theta then? Then theta will be 90. That is why it is so. Second, no two equipotential surface intersect. If they intersect at the point of section, there will be two directions, which is not possible. Most important, that if equipotential surfaces are very close to each other, then it represents strong electric field. If equipotential surfaces are very far from each other, then it represents a weak electric field. It means, why it is so? We already proved that E is inversely proportional distance. More is the distance, less will be the electric field. Less is the distance, more will be the electric field. It means this will be decided by the distance. This will decide whether the electric field is strong or weak. Next, after this, the question comes: draw the equipotential surface for a point charge dipole, uniform electric field. All these diagrams are given in the notes, so you can see from this. Next, the most important maximum times the numerical come from this, that is called electric potential energy. Most important হচ্ছে electric potential energy.